All right, good morning, everyone. It seems like no one has joined me on Zoom yet, but it's all right. Since I promised I'll go on Zoom at 8:20, I did not prepare any live sessions. I did not prepare any videos in advance for this tutorial. So let's just get started with this bunch of questions on organic chemistry. We have a structure of 4 organic compounds. So this is very clearly an alkane. How do I know it's an alkane? Because everything is saturated. This is called a saturated hydrocarbon. There are 2 bits to this definition. Hydrocarbon means it's a compound containing carbon and hydrogen atoms only. If you look at the structure above, there is only carbon and there is only hydrogen. And I know it's saturated because all the carbon is single bonds. So the carbon doesn't have any multiple bond, all of them are single bond. So that means it's a saturated hydrocarbon, which means it must be an alkane. There is your CnH2n plus 2 family. On to the next one, you have the characteristic alkene. With an alkene family, this is what you call it unsaturated. And it is also a hydrocarbon because it's a compound containing carbon and hydrogen only. So it's called unsaturated hydrocarbon. For the same reason, it's got compound containing carbon and hydrogen only. Unsaturated means it has multiple bonds. So in this case, it has carbon-carbon double bond. Unsaturated means it's not yet completely used up. So it's got these double bonds, which allows addition reactions onto alkene, onto alkene, E and E. All right, whereas alkane only undergo substitution reaction because it's already saturated. So alkene is CnH2n plus 2 there. Oops, I beg your pardon, CnH2n. Anyway, on to the next one. You have the characteristic alcohol group. So this is the alcohol. So it's got the OH, and this is a C2H5. 1, 2, and then 1, 2, 3, 4, 5 hydrogens. And then we write OH. This is a 2-carbon alcohol because 2-carbon is called MEF. If. Don't know what's wrong with me today. There's 1 carbon for MEF. If is 2 carbon. Prop is 3 carbons. You got to know until at least 4 carbons as required in your syllabus. This is stated in the Combined Science 5129 syllabus that students or candidates should know up to 4 carbon, MEF, eth, prop, and bute. This would be methane, ethane, propane, butane. There's no 1 carbon alkene because you need at least 2 carbon for carbon-carbon double bond. So what you have is ethene, propene, butene. Here you have methanol, ethanol, propanol, butanol, something like that. On to the last one, you also have the same thing, which is a saturated hydrocarbon because all of the carbon-carbon bonds are single bond. And you have how many carbon here? 1, 2, 3, 4, 5. You have 5 carbon altogether. Okay, so this is C5H12. Unfortunately, this is not what you call pentant because this is branch. These are something that I'm not entirely sure that you have done isomers, but this is an isomer of a 5-carbon alkane. So looking at the questions, and alkenes, the keyword alkene there stands for carbon-carbon double bond. So very clearly there is option B because that was what we have just taught about in the question. Alcohol, very clearly there is C because there is the OH there. Oxidized to a carboxylic acid. In the context of organic chemistry, oxidation means gain oxygen, and also or lose hydrogen. So you can imagine that when you lose these 2 hydrogens, so you can lose this hydrogen and this hydrogen, and you gain oxygen, you get carboxylic acid, which is going to be like this. So the carbon still form 4 bonds, 1, 2, 3, and 4, but the carbon there, which is this important carbon, the blue one. So it has lost the 2 hydrogens and it has gained oxygen. Everything else doesn't change. That is called oxidation. Alcohol is further oxidized to a carboxylic acid. 2 of the compounds are alkanes. So alkane is A and D. If you look at A, 1 carbon, 2 carbon, 3 carbon. So A is a 3-carbon alkane, whereas D, just now I say it's a 5-carbon alkane. Oops, I beg your pardon. 5-carbon alkane. So, you know, the 5-carbon alkane, 5-carbon alkane has longer chain. So as you have learned in fractional distillation, longer chain, higher MR. So there are more electrons in the molecule. So higher MR, therefore higher boiling point. Now, all 4 compounds burn in excess oxygen. Excess oxygen there refers to combustion. So what happened in combustion is they want the names of the 2 products. So we're looking at complete combustion because there's excess oxygen. So we know that it's carbon dioxide and also water. In certain years, they would like to ask you the formula. The formula will be H2O and CO2, but these are formula. And when they ask for names, which they did here, so you have to give the names instead of the formulas. All right, so let me just go a bit faster now. So octane is a component of petrol. As you can see from the name suggests that it is an alkane family. So homologous series there will be alkane. Octane contains 8 carbon atoms. As you know from alkane, you have CnH2n plus 2. So complete the formula. Well, in fact, they already gave you the complete formula. There is a complete formula. When there's 8 carbons, then 8 times 2 is 16, plus 2 is 18, so it's CnH18. What bonding is present in a molecule of octane? When you draw alkane, you will have molecules like these. So inside the molecule, you have this thing which we draw as line. Each of these line is between non-metal and non-metal. So non-metal and non-metal will form covalent bonds. So, you know, they are between non-metal carbon and non-metal carbon, or they are between carbon and hydrogens. So covalent bonding involves the sharing of electrons. You think about it, you have this thing, these are sharing electrons between non-metals and non-metal. So each of these, a pair of shared electrons equal to 1 covalent bond, as something you have done in year 9. It's something I normally teach in year 9 these days, okay? Question 9 is about boiling point. They want you to complete the molecular formula. Molecular formula means you got to know the general formula, which is, well, they've already given you in the question very nicely. So hexane is 6 carbon, so C6. And then 2 times 6 is 12 plus 2 is 14. Here, there's no formula for this, but you just have to be a little bit sensible. 4 carbon, 5 carbon, 6 carbon, 7 carbon, and 8 carbon. How do I know this? Well, you look at the formula. Okay, so this is as the carbon chain increases, number of carbon increases. This is longer chain, or you say larger relative molecular mass, MR. So year 9 and year 10 students have learned this, larger MR, and therefore higher boiling point. So these are your explanation. But looking at this increased by around 30, this increased by around 30, I think give or take around 30, 95, something like that, 95, or you can say 90, whichever one you like. Somewhere that makes sense, somewhere where it's not 69 or 120, somewhere in between these and these, around 20 to 30 degrees Celsius should be all right, I guess, okay? That's why it's an estimating question. You should think a little bit, but not like think so much into it. On to part B, characteristics of a homologous series. As you know, a homologous series like this, if you look at this thing, this is a homologous series. Look at the trend, going from here to here, you have add in a CH2, going from there to there, you add 1 carbon, and you add 2 hydrogen. So each member in the series, they increase by CH2. So each member, I mean, all of these, you have it in your notes anyway, increases by CH2, okay? What else? There are, I mean, characteristic of homologous series. Well, you can talk about this as the number of carbon chain increases, as the chain increases in length, meaning to say they gets longer, they gets bigger. So with more carbon, then larger MR, longer chain, higher boiling point. These are 2 that comes on top of my mind, but I'm sure there are more than just 2. I think 5 or 6 in your notes, really. This very last one, so I wouldn't draw completely onto it, but you know, 2 carbons, C2H6, make sure you have single bonds because it's an alkane. So we will draw alkane like this, carbon from 4 bond, 1, 2, 3, and 4, hydrogen from single covalent bond, and the name of the products. Again, they want the names, so make sure that you always read the questions and not just give formula, as I would normally do, but I know how to read questions, so I know not to get tricked by it, okay? Yeah, I'll probably spend another 3 more minutes on this, and then I'll start recording, and you can get on with the rest of the question. So this is about drawing lines. So this is a factual question. So you need to know your fractional distillation, what is used for what. Heavy oil is not going to be used for making jet aircraft fuel. Let me think. Fuel for car is definitely petrol. Making roads is bitumen. So there's the really black substances. I think between this and this, I think we might be right. Hang on. Heavy oil, I think, is waxes and polishes. Am I correct? Let me think. I might be wrong. Okay, I better check on this. Okay, I might be wrong, but I know bitumen is making roads. Yeah, I might be wrong on this. Okay, let me just skip on this and I'll come back to it later. Okay, so step 1, characteristic of a homologous series. Alkanes, if it is alkane, they have general formula. So I mean, very obvious. So show the examiner you know what you're talking about. Alkane has general formula, CnH2n plus 2. Well, you want octane, so it's N equal to 8. So C8H18, because 8 times 2 is 16 plus 2 is 18. Name the main constituent of natural gas. What is this? Butane, natural gas are fossil fuels. Name the main constituent of natural gas. I have no idea. I would have thought that it's butane, okay? But I think it is butane because natural gas contain mainly butane. Hydrocarbon, I mentioned earlier, a compound containing hydrogen and carbon only. So very, very important. They like to ask you definition like that. A compound containing hydrogen and carbon atoms only. These are the kind of things that we can imagine. So yeah, I mean, paraffin, as you go higher up, okay, let me just think about it, okay? So this is higher boiling point as you go further down because it's longer chain, longer carbon chain, and there are, let's say, larger molecule. So larger molecule, and there is higher MR, higher relative molecular mass. Therefore, boiling point increases. As you can see, petrol is there, paraffin is there. Petrol is used in car engines, and kerosene is used. Oh, okay. Paraffin is also known as kerosene. Now I know where I got my answer. Paraffin is also known as kerosene. Kerosene is used for jet